This is your exam review for 6 and 7. And so this begins your theme 2, which is about planning a study, and it talks about overview of methods of data collection. So in the real world, collecting information from an entire population would be almost impossible. So, for example, it's incredibly difficult to question every American about their employment status before announcing the monthly U.S. unemployment rate. So, when we study statistics, a lot of times we will estimate a population or characteristics of a population by considering a sample. However, if you're going to use a sample, you've got to make sure that that sample is a great representation of your population and that you are doing all that you can to reduce bias. So one method of data collection is called a census. And so a census is when you ask every single person in an entire population. And so the census that you're probably the most familiar with is the U.S. Census that occurs every 10 years. And so essentially with that, they divide the nation into 9 regions and they attempt to gather as much information about everyone in the country as possible. And so they try to get things like age and marital status and race and gender and occupation, income, years of school completed, and so on. And so although they do a really great job of trying to get as much information as possible and will absolutely hound you to death to get that information, there are times that the census is not incredibly accurate because there are so many people and it's difficult to get to everyone, and you may miss people in the process. So, for example, many homeless people are missed or counted at 2 temporary residences because they may be bouncing around from place to place, and they may coincidentally be in one place one day where a census has been taken, or a census is being in the process of being taken, and then at a different location the next day where a census is also being or the action of the census being taken is also taking place. So there are always households that do not respond even after there have been multiple requests for information. And so it's actually estimated in the 2010 census that there were about 2.1% of Black Americans and 1.5% of Hispanics that were not taken into account in the census for 2010. And so together those two subgroups accounted for about 1.5 million people that were missed. So although a census, the intention of a census is to contact every single person in a population, sometimes that is difficult. Another method of data collection is a sample survey. And so while a census tries to count everyone, it is not a sample. A sample aims to obtain information about a whole population by studying part of it, and that part is what we call the sample. So the goal is to gather information without disturbing or changing the population. However, bias is something that you have to watch for whenever you are taking a sample, because you want to make sure that the sample that you're taking is not going to lean in one direction or the other, and that you're going to get useful information from that sample. So the main technique to avoid bias is to incorporate some sort of randomness into the selection process. Randomization protects us from the effects and influences both known and unknown. And finally, the larger the sample, the better results are. So what is critical is the sample size, not the percentage or the fraction of the population that you're looking at. So what that means is essentially if you take a sample of 500 from a population of 100,000, you are getting just as much information from those 500 people as you would if you took a sample of 500 people from a population of 1 million people. So when you take the sample, you're looking for the number of people that from each group. An experiment is a controlled study, and so in an experiment, the researcher, whoever is performing the experiment, should randomly divide subjects into appropriate groups, and some action is taken on one or more groups. So the purpose of an experiment is that you are looking to see some sort of cause and effect relationship. So there should be some sort of action that is being taken on at least one of the groups in order for it to be considered an experiment. So, for example, patients may be randomly given unmarked capsules of either aspirin or acetaminophen, and the results of the medication measured. Experiments often have a treatment group and a control group, and so the treatment group is the group that is receiving some sort of drug, or there's something that's happening to that group, whereas the control group is the group that is either receiving a placebo, a drug that is not, or a pill that is not actually the drug, or they may be just a group that you're not doing anything to and you're just watching. And so it is the ideal situation that neither the subjects nor the researcher know which group is which, so which group is the treatment group and which is the control group. And so this is what we call a double-blind experiment. Controlled experiments can indicate cause and effect relationships. And so that's the purpose of having these controlled experiments, is that we can say for sure that a particular treatment is having an effect. The critical principles behind good experimental design include control. Outside of who receives the treatments, conditions should be as similar as possible for all involved groups. Blocking. The subjects can be divided into representative groups to bring certain differences directly into the picture. There also should be randomization, so unknown and uncontrollable differences that are handled by randomizing who receives what treatments. You should be able to replicate the process, so treatments need to be repeated on a sufficient number of subjects, and generalizability, and so this should be that you should be able to repeat an experiment in a variety of different settings. Another method of data collection is an observational study, and so sample surveys are one example of an observational study. Remember, with sample surveys, your goal was to kind of make sure that you did not do anything that would affect, you're just asking questions. So in observational studies, there is no choice in regard to who goes into the treatment and who goes into the control. And so, for example, a researcher cannot ethically tell 100 people to smoke 3 packs of cigarettes a day and 100 people to smoke only 1 pack a day. He can only observe people who habitually smoke these amounts. And so you, in an observational study, are doing exactly what it sounds like. You are just observing. You are not doing anything. You're just watching. And so think about it almost like being at a zoo. You're not doing anything to those animals. You're just watching. So in observational studies, the researcher strives to determine which variables affect the noted response. While results may suggest relationships, you cannot conclude cause and effect in an observational study. You can only do cause and effect in an experiment, not an observational study. So observational studies are primary vital sources of data. However, they are a poor method of measuring the effect of change because of that inability to conclude cause and effect. To evaluate responses to of change, one must impose change, and that is to perform an experiment like we've been talking about. And furthermore, observational studies are on the impact of some variables on another variable often fail because explanatory variables are confounded with other variables. And so when we talk about being confounded, confounded means it's kind of hard to tell if the result is from one particular treatment or by this other thing that kind of lurks in the background. All right, so we're going to move over into your review 7, and so this has to do with planning and conducting surveys. So when we were discussing how you go about doing surveys, one thing that we mentioned over and over again was random sampling. And so simple random sampling comes from when you choose, or the way that you choose a representative sample of a population. And so it means that you are randomly choosing people to participate in that particular survey. So your sampling method must give everyone in a population an equal chance of being selected as part of the sample. You may use a random number table or a random number generated by a computer to choose a simple random sample. So characteristics of a well-designed, well-conducted survey. So a well-designed study always incorporates chance, using or such as using random numbers from a table or computer. However, the use of probability techniques is not enough to ensure a representative sample. So often we don't have a complete list of the population, so you have to be careful about exactly how you go by applying this idea of chance. So even when subjects are picked by chance, they may choose to not respond to the survey, or they may not be able to respond. That should say able. May not be able to respond, thus calling into question how representative the final sample really is. The wording of the question must also be neutral, because sometimes the way that questions are worded will make subjects or the people that are answering the question answer in a particular way. So, example 7.1. Suppose we are interested in determining the percentage of adults in a small town who eat a nutritious breakfast. How about randomly selecting 100 numbers out of the telephone book, calling each one, asking whether the respondent is intelligent enough to eat a nutritious breakfast every morning? What are some issues with the way that particular survey is being conducted? So, one thing that might be a problem is that the way that you are choosing may not actually be as random as it seems. So, for one, you're selecting out of a telephone book. And so you have to take into account how many are unlisted in this town. And so if you are using a telephone book, you're going to completely leave out this whole group of people who are not listed in the phone book. The other thing that might cause some issue is the way that this is worded. So whenever you're asking the respondent if they're intelligent enough to eat a nutritious breakfast, it almost implies that if they say no, they don't eat a nutritious breakfast, that they're stupid. So you've got to be really careful to make sure that you are not, by using that word intelligent enough, that you're not kind of leading the participants in a particular direction with the way that the question is worded. Sampling error. So no matter how well designed and well conducted a survey is, it still gives a sample statistic as an estimate of the population parameter. So different samples give different statistics, all of which are estimates for the sample population parameter, and so error, called sampling error, is naturally present. This error can be described using probability. That is that we can say how likely we are to have a certain size error. Generally, the chance of this error occurring is smaller when the sample is large. However, the way the data is obtained is crucial. A large sample size cannot make up for a poor survey design or faulty collection techniques. Only a complete census can prevent sampling error. That is, whenever a sample is taken, sampling error will be present. So, no matter what, whenever you take a sample, there is sampling error. The only way that you can completely eliminate sampling error would be to take a full census and make sure that you had everyone in population participate. Example 7.2 says each of the 4 major news organizations survey likely voters and separately reports that the percentage favoring the incumbent candidate was 53.4%, 54.1%, 52.0%, and 54.2% respectively. What is the correct percentage, and did 3 or more of the news organizations make a mistake? And so with this particular problem, there is no way of knowing the correct population percentage from the information given. The 4 surveys led to 4 statistics, each an estimate of the population parameter. So each of the percentages that you have was just an estimate of the population parameter. No one made a mistake unless there was a bad survey. For example, one without the use of chance or not representative of the population or with poor wording of the question. And so the sampling differences that you are seeing there, because you're talking about the exact same survey being given to people, the reason that you're seeing different numbers there instead of them all being the same is just what we call sampling error. So that's just an example of what you could see there. Your sampling differences that you see there are completely natural. All right, sources of bias in surveys. So poorly designed sampling techniques result in bias, the tendency to favor the selection of certain members of the population. So that's bias. If a study is biased, size doesn't help. So it doesn't matter how many people you have in your survey. There's no way, if it's biased, that you can get any valuable information. You have to consider bias before you run a study, because once you have the results, there's no way that you can then eliminate the bias from the results. So some different types of bias that you might run into. Household bias is when a sample includes only one member of any given household. So members of large households are underrepresented. So an example of this would be like the Duggar family, like, what is the name of that show? 19 Kids and Counting. If you went to that house and you just asked one person, there are 19 kids that live in that house, or 20 people that live in that house, you are completely leaving out the other 19 people if you only ask one person, whoever comes to the door. Non-response bias. So people chosen for a survey, but they do not respond to the survey, or they're unreachable or difficult to contact. So this would be like if you sent out surveys in the mail. If you send out surveys in the mail, most people probably are not going to put those back in the mail. So those people are then going to become difficult to contact, and so that would therefore be non-response bias. Quota sampling bias. So this is possible when interviewers are given free choice in picking people to participate. And so interviewers may focus on obtaining a particular percentage of a certain gender or race. And so, like, for example, they may be focused on, like, only obtaining a particular percentage of men or a particular percentage of Catholic individuals. So this technique resulted in misleading polls, leading to the Chicago Tribune making an early incorrect call of the Thomas E. Dewey as the winner over Harry S. Truman in the 1948 presidential election. Response bias, and so this is when chosen participants respond how they think makes them look best. So this is like when you go to the doctor and they ask you, do you exercise? Or like when you go to the dentist and they say, do you brush your teeth? Actually, no, do you brush your teeth? Like, you should definitely brush your teeth. But do you floss? That's a question that, like, most people probably don't floss. But when they go to the dentist, they're going to tell their dental hygienist that they do floss just to make themselves look better. Selection bias. So this is when chosen participants are not representative of an entire population. And so an example of selection bias would be back in the 1936 election, presidential election, Literary Digest opinion poll predicted a landslide victory for Alfred Landon over Franklin Delano Roosevelt. And so the reason for that particular incorrect prediction was that the Digest only surveyed people with cars and telephones. And if you think back to what was happening in 1936, that was probably your more wealthy people. And so, but those more wealthy people were in the minority at that point. And so this particular digest was choosing to only talk to a certain number of people, and those were the people who had more money, and in that point probably would have voted in a particular way like as a particular party. And so by selecting that particular group, they got a not very good representation of what was actually happening. Size bias, an example of size bias would be like if you were throwing darts at a map to decide which states to sample. If you are throwing darts at a map, you're probably going to hit geographically more of the larger states because they take up more space on the map, and so that would be an example of size bias. Another example would be like if you had a bag that had a bunch of coins in it and you were asking students to choose coins from the bag to represent how much money was in that bag. Obviously, your bigger coins, your quarters, are going to be what people probably go to first. They're probably going to skip the dimes or the pennies. Undercoverage bias. And so this happens when there's an inadequate representation. And so undercoverage bias would be like that example that we talked about with the telephone book. If you're using the telephone book to obtain the numbers for the people that you're going to call only people that are in the telephone book, and you're going to leave out all the people who are unlisted or who don't have landlines. Voluntary response bias, and so this is samples based on individuals who offer to participate. And so think about this being like people that call in on the radio. So whenever disc jockeys on the radio ask questions and they ask people to call in to respond, people that feel strongly are going to be the ones that are more likely to respond. You can also think about this as being like Facebook surveys. Wording bias. We've seen wording bias today whenever you were looking at the question that talked about asking people, are they intelligent enough to eat breakfast? And so wording bias is basically when you have non-neutral or poorly worded questions that which may lead to answers that are very unrepresentative of the population. So some other sampling methods that you might have is systematic sampling, which basically just means that you have a system to how you choose participants, whether it be that you give every person a number and then you randomly select a number. Stratified sampling means that your population is divided into homogeneous groups called strata, and that random samples of persons from all strata are chosen. And so this is basically choosing some from each group to participate in your sample. Cluster sample is the population is divided into heterogeneous groups called clusters, and you take a random sample of clusters from among all the clusters. So it's basically like choosing one group to participate. So if you thought about, if you divided, so we did this in class forever ago, we divided our class into people based on their eye color. In a stratified sample, that would be taking 2 blue eyes, 2 green eyes, 2 brown eyes. In a cluster sample, it would be like choosing from the blue eyes, the green eyes, or the brown eyes, that you are only going to look at the people from the group that have brown eyes. And finally, multi-stage sampling just means that your procedure involves 2 or more steps.